Now let's discuss one more theorem. And as per this theorem, if f and g are real valued functions such that the composite function f of g is defined at the point C, and if g is continuous at point C and f is continuous at the point g of C, then the composite function f of g is also continuous at the point C. Now let's try to understand this theorem with the help of some examples. And in our first example, show that the function defined by f of x equal to sine of x square is a continuous function. Now since this is sine function, so that means the function sine x is a continuous function and it is also defined for all values of x. And now x square is equal to x into x. So that means now the given function f of x equal to sine x square can be also written as a composition of two functions or g of h, where g and h are two functions such that g of x is equal to sine x and h of x is equal to x square. And we have already proved that the function sine x is a continuous function, and also the function x square is also a continuous function. And now because g and h are both continuous functions, and now as per this theorem, the composition of this function g of h or sin x square is also a continuous function. Now let's do one more example. Show that the function f defined by f of x is equal to modulus of 1 minus x plus modulus of x is a continuous function where x is any real number. Now let's define g by the function g of x, where g of x is equal to 1 minus x plus modulus of x, and let the function h be defined as h of x is equal to modulus of x for all values of x where x belongs to real number. Now the composite function h of g of x is equal to h of g of x. Now g of x is equal to 1 minus x plus modulus of x, and h of x is equal to modulus of x. So h of g of modulus of x is equal to modulus of 1 minus x plus modulus of x, and which is equal to f of x. And in the previous episode we already proved that the function h of x or the modulus function is a continuous function. Similarly, the function g of x, which is a sum of a modulus function and a polynomial function, is also a continuous function, because if f and g are two continuous functions, then the sum of f and g is also a continuous function. And now since both the function g of x and h of x are continuous functions, then as per this theorem, the composition of these two functions or h of g of x or modulus of 1 minus x plus modulus of x is also a continuous function. Now let's do one more example. Discuss the continuity of f of x equal to sine of modulus of x. Now here, the function sine of modulus of x can be also compared to composition of two functions in which the first function will be sine x and the other function will be modulus of x. So let g and h be two functions where g is defined as g of x is equal to sine of x, and similarly the function h is defined as h of x is equal to modulus of x. Now the composition of these two functions g and h is g of h, and which is equal to sine of modulus x. And in the previous episodes we have already proved that the function sine x is a continuous function, and also the function modulus of x is also a continuous function. So, and by the theorem which we have just stated, if g and h are two continuous functions, then the composition of these two functions is also a continuous function, and which means if sine x and modulus of x are continuous function, then in that case the composition of these two functions sine of modulus of x is also a continuous function.